we are live. The first day of Meeting C++ closes with an AMA by and with Andrei Alexandrescu. And with that, I'd like to welcome Andrei Alexandrescu.
Thank you, Jens. By the way, this is like the best pronunciation of my name in the Western Hemisphere. Congratulations. Thanks very much for having me at Meeting C++.
Okay, I get the confirmation that this is working in the room, and I also see the first questions. I'd like to start with a question. We had a keynote about ranges and views and concepts this morning. So I would like to ask you, what's your opinion on views and ranges in C++ 20?
I'm not sure what I missed the keynote because I was working incidentally
I'm not
on
expecting the keynote. Just what's your general? Do you have an opinion on that?
Sure.
On the ranges.
I'm not. I don't have a shortage of opinions. Yes. So I think of course, I love ranges. Ranges are something that I've been working quite a number of years, literally, in the D community, and I think ranges are not only sort of a handy way to use iterators, but are fundamentally a step forward. So I like ranges a lot. Views are also, in the same category. So very often you need a way to access a subset of a larger container. The only problem I see, and essentially there's this problem that exists in the C++ language, and it not being solved, it's carried along with everything else, is safety. So iterators and ranges and views are all in many ways unsafe, and that makes them dangerous at times. I'm not saying they're not necessary, but they do come with caveats. A view can expire outside of its container, and etc. And so it can happen with iterators and ranges. So I like, it's not that I like. I would say they're as necessary as, they're survival. You gotta have them. Like, if you ask me, like, does a house have to have like a can opener? Yes, it should. It should have a can opener. It doesn't mean I love can openers or that I dedicate my life to them, but at the same time, between can openers, maybe I want a safer one. Maybe I'd want one that I'm not cutting my hands with easily.
You mentioned safety. There's a question about safety, and that is, are there any lessons learned about memory safety that C++ can learn from D?
I wasn't expecting such a question. I was expecting a question involving the Rust language, which is more sort of to the forefront of safety nowadays. By the way, should I see the questions myself, or you're just like?
I just sent them in, and the audience sees the question, and I asked you the question. Okay.
Awesome. Okay, I'm not seeing them, so I can't pick and choose. I think so. Speaking of so I have C++, we have Rust, and we have D. So that these three languages that have a word to say about speed and safety. And Rust has gone, the whole way, and they say we're gonna do absolutely everything we can for safety. And in process of doing so, we're gonna require you to write your code in quite a different way. So Rust code is very often looks foreign to people, and D somewhere in between, which makes the whole thing quite interesting. D currently does not have a borrow checker, which is the quintessential way of ensuring safety in the Rust language. And there is work by Walter Bright right now. We keep in touch, and we discuss quite a bit his work on type safety, and he has an idea that I think is quite interesting, which is safety for references and pointers, and everything within directions, would be an attribute on the object. And that means you have the option of saying, I just want the references to this particular object to be tracked, but this other object I trust, or I don't care about, or whatever. It's not of interest to my safety pursuit. So you can have a mixed mode whereby you can mix pointers that are safe with pointers that are not necessarily safe, and that's done via attributes. Attributes in D are quite similar to those in C++. So that makes it interesting from a migration perspective. And here's to get to the question. Here's where I think C++ could take inspiration from the D language, because you can't go from C++ to a Rust style way of doing things, because it requires redesigning everything, right? But you can actually say, you know what, I'm going to say this particular pointer, iterator, range, view, or whatnot, I'm interested in making safe. So you can migrate from an unsafe style to a safer style by using attributes. That's not finalized in D, but there's an article on it, and I can essentially send the link after this talk to anybody interested. There's an article about how this is implemented in the D language, and there's an interesting consequence as to speed of compilation as well. The Rust compiler the borrow checker is famously slow, because it needs to do a lot of O of n algorithms. There's many O of n algorithms, at any place placing the code. So then C++ compilers are also slow for different reasons. So probably the last thing you want is have a feature that makes compilation times in C++ like 5x slower, right? So you don't want that. What D proposes is, you know what? Yeah, you're gonna pay those prices, but only for the types and objects that you actually want to track and make safe. So I think migration is the important lesson that C++ could get inspiration from.
Do you have a favorite IDE?
Do you have a favorite IDE? I've been somewhat of mercenary with IDEs. Like I've been a long time Visual Studio user back in the I don't know, early 2000s. I was like using Visual Studio and Windows like everybody else during those times. Before Linux became more ubiquitous. And once I started in the graduate program, I started using Linux. Emacs was a natural choice. For some reason, I never got into the VIM camp or land or way of doing things. But I don't think there's any interesting conclusion to be drawn. There's nothing can infer about my mental health or whatever by saying I'm using Emacs and not VI. So I'm an okay Emacs user, but I never use it's powerful. I wrote my macros and stuff just to make it more like Visual Studio, I guess. And nowadays I'm programming CUDA for the most time, and I just again, path of least resistance, Visual Studio Code. It works on Ubuntu, and for some reason, it was a mistake in scheduling. The company installed Windows for me instead of Linux. So I got a Windows machine. I was too lazy to kind of give it up and install Ubuntu instead. So what I did, I put this WSL. I'm not sure you know about it. Yes, it's Windows subsystem for Linux. So essentially, you have a complete emulator of Linux under Windows, and it runs at 99% speed. So I'm good. And Visual Studio works on that. So I'm using Windows with Ubuntu on top and with Visual Studio Code, which is by Microsoft. So it's a weird Frankenstein I'm using right now. But in essence, let's say Visual Studio Code. Now, the funny thing is, and it's really quite a coincidence that this favorite ID question came up, is, well, I started using GDB, like Back to the Future. Come on. So I started using GDB because it's the most accessible thing to use in the whatever Frankenstein setup I have. And here we are. I hope there's no interesting conclusions that can be drawn about me for using GDB.
Yeah. So, do you are you currently working on any books, especially like C++
Ah,
books?
am I currently? So I think there is a need for a book. So I'll reply obliquely. So I think I got back to C++ after a hiatus. So I've been for a long time. I wrote no code in C++. I wrote a lot of code in the D language. So that was for years. It went for years, and then I think it was about since the pandemic started. Um, I got burnout. I got burnout from being like a prominent member in the D community and leading the community. So I said, how about some fresh blood? So how about changing the leadership there? And I proposed somebody else to be the leader, and that's going well, and that's nice. That left me with an empty heart, if you wish, that left a vacuum of whatever. So I was burned out from that work with the D community, and I was like, you know what? So let's see what else is there. So Eric Niebler actually was very excited about his work at NVIDIA. He was, oh yeah, you should join, and that'll be fun, and that'll be awesome, and it's all of this these parallel algorithms and a lot of good stuff. And so I joined NVIDIA, which is a great company, and it's really nice work. And I'm in research, so I have a relatively long leash, if you wish, as to what I'm working on. So anyway, now to answer the question, I think I'm going to have a book in me. There's a special feeling. I have a book in me. So there's this feeling that, do you have a book in you or not? Are you, pregnant with a book, if you wish? Or, is there like the seeds, the idea, or the premonition of a book inside your mind? And I think there is. And many people say, oh, so, you wrote modern C++ design. What's the title of that next book? Postmodern C++, whatever. And, modern C++ has become right now kind of a common phrase, and everybody uses it. Oh, that's C++ with a bunch of templates and stuff. But I think there is a need for a book that would be neoclassical C++. And if I ever write one more book on the C++ language, it's going to have that title, Neoclassical C++. I'm not sure it's so neoclassical means you use modern techniques, but you return to a few classical values. And I think classical values are something that the C++ community yearns for, wishes a return to that sort of a classical purity of C++. Now let me give you an example. How many sub languages, Jens, do you think are in the C++ language?
And
Non-rhetorical question. And I'm opening this question for anybody in the audience to answer to or kind of think about. And I'm
yeah,
not going to provide a precise count, but just like grosso modo speaking, first of all, like there's like the preprocessor, which is like complete different language, and the hell with it. Just take it out of the way. I don't want to talk about it that much, right? So the preprocessor is a different language from the rest of C++, and I think there's no disagreement about that within the community. But then there's a bit of a kind of a federation of different other sub languages, each of which has its own kind of stake in the ground and its own kind of its own like pea on the trees around the landscape there, right? It's marked its territory, each style of programming. There will be like the OOP, object-oriented programming. So you have objects and you have virtuals and you have best match. Whenever I call a virtual, the best match is found. And you have overloading and overriding rules, and you have all of these nice things. So that would be another sub language. Of course, there would be like the C, like plain C sub language, which is its own thing there. And then you have the object-oriented additions. But then it gets a fair amount more complex and interesting. So you have like templates, and templates have different rules as to, for example, like how overload interacts with templates. They're very different rules. So the templates come on top of overloads, but not in a kind of smooth, natural way. They're kind of different rules, right? It is best match, but it's different. There's
yeah,
partial ordering, and there's kind of a whole different algorithm that deals with how you match templates. So then you have like the whole template language and all of the interesting things people do with templates. And you need to learn a whole different way of doing things. Let's agree on that, right? For example, what I would do with a loop in C++, right? In the like the preternatural, whatever, simple C plus, let's say, right? C plus with a single plus, like the simple C plus. I would do like a loop. Well, wait a second. In template world, I need to do recursion because there's no looping and there's no iteration. There's no that kind of stuff. And people are kind of said, yeah. So there's a whole market of intelligence developed around that skill set. A whole market. They're experts in templates. They're not necessarily experts in C++, but experts in C++ templates. So in that specific sublanguage, not to say they're world-class experts in the preprocessor. So that's kind of a weird world of its own. It just again, like the backers keep on coming back. So let's push them aside for now. So we have this other style in C++, which is like templates, and you have like whenever you use recursion, and there's no if. So you don't end your recursion with like if n is 0, then I'm done with recursing, like whatever. There's no if. What is there, Jens? How do you end the recursion in C++ templates? How do
That's
you
a
have
good
like
question.
recursive factorial, right? And you want to
Yes,
compute
it's
factorial recursive,
recursive.
and
Okay.
exactly. So you define a
And then it's an
specialization.
overload.
Oh, I'm gonna specialize for 0 or whatever the hell, right? And I'm gonna end the recursion. So there's a specialization. So there's no if in that language, in that sub language, which is very interesting. There's no iteration and there's no if, right? But there's like giving names to things, and that's still like a good thing. You can give a name to the factorial and that kind of stuff. And there's this new template using thing which helps. And so okay, so we have that whole world. But wait, there's more. Then came along variadics. So, so with variadics, you have this whole yet another different style of programming, which is there's no if, there's no looping, there's no giving names to things. You can say using a equals pack. You can't give a pack a different name, and it looks like what do I care? Like I can use the original name. No, no, no. Wait a second. If you can't give things a name, you can't return them from functions. For example, you can't compute things. So that's a fundamental right of C++ programmers that should be enforced by like the Hague. The tribunal at the Hague with international human rights should enforce the fact that C++ programmers should be able to give names to things. So this is like a absolutely fundamental thing that I want to do. I want to say, oh, this thing that you call A, I want to call B. And that's, from here on, I'm going to keep using B. So that's an important thing because that means you can, you can return B, you can pass it to another, you can do computation if you give names to things. But with packs, you cannot give names to things. So that's a whole yet another different style of programming where you don't have iteration, you don't have if, and you can name things. With templates, you don't have if, you don't have iteration, but you can give names to things. With traditional programming, you could do all of these things. You can give names to things, you can create temporaries, you can copy things, you can modify things, you have absolute freedom. So that is that is classical C++. When I can do whatever the goddamn hell I want, the way I want, with loops and with if and with else and with while and with switch if I so want, and so help me God, okay? All right, so then comes the template thing, which I can't do most of these things, but I can do all of these recursive weird things, and I kind of it still makes my day. So I'm still in good shape. But then comes parameter packs, where I can't do any of these things. So then people come with a variety of techniques for parameter packs, and they're mind-boggling. Like I'm talking to colleagues here. Oh, I need to apply a function to every element in a pack, and it's just like a mess. And they're like, oh yeah, I have a little library that does that thing. It's like a little master thesis that I need to read to figure out how to do something that's really simple with a pack. And then, but wait, yes, there's more. There's also concepts, and C++ concepts there's no equivalent in natural life, right? There's no like simple thing I can compare them to. Like I could say, oh, template are like a weird functional programming thing. parameter packs are like a weird Lisp macros thing, and C++ concepts are like something that doesn't look like anything. And there's like the requires keyword. What's wrong with if? Why is there, yes, why is there requires keyword in the C++ programming language? What's wrong with if? Because if means requires. This happens if that happens. Ta-da-da requires ta-da-da. Ta-da-da if ta-da-da. Case closed. But no, we're gonna add a new keyword which is actually a common language. But anyway, so concepts are their own sub-language within C++, right? So then we have this federation of mini languages that compete with one another, and in which the way of doing things is very different from one another. I can't do with a pack what I can do with classical C++, and I can't do with a pack what I do with a template, and I can't do with a concept what I do with a pack, etc. So I think what is needed, what's needed for this community, which has is yearning, is wishing to return to some classical values, is the classical C++ book. Yes, the classical C++
Okay.
book, the neoclassical C++ book, which means I want to iterate a pack, I want to iterate a template, and I want to iterate whatever concepts, I want to iterate members of a class and everything in the same way everywhere. And that's why I'm insisting on the whole reflection thing, because reflection offers this promise of saying we can unify all of these by writing very complex metaprogramming code with if and for and while and whatnot. That was that too long an answer?
Yeah, so
It's like
that's going to be an interesting book. That's
I
going
would
to
love
be an
it.
interesting book.
I would
Um,
yeah, go ahead.
we've just been a little bit in the right direction regarding a question for languages. And so, do you have an opinion on recent emergence of Carbon Lang and CPP1/CPP2 that more or less try to, modernize and give a better
Yeah,
syntax?
this is very interesting. I think our community is at an interesting crossroads. These are science that the C++ language is. There are people dissatisfied with either the language or the way it's being managed and evolved and that kind of stuff. And Carbon, I remember it. For example, there's like uh, the Google programmers wanted some ABI breaking changes, and essentially those are not approved. It's not going to happen. So a good amount of the effort for defining Carbon was, you know what, we have the freedom to define a better ABI. So definitely there is a bit of there is again the whole yearning thing. I'm not sure I'm pronouncing it even yearn, like to wish, to strive, to wish something really hard, like yearn. Wish for something of spiritual nature, if you wish. And I think the spiritual need of C++ programmers, if you wish, is that C++ was more um, self-consistent, because both Carbon and
Hmm?
CPP front do offer that. They do offer a fair amount more self-consistency and a unified syntax, and simpler means for achieving more difficult goals. In C++, there's been a bit of a loss of the way, in the sense that people have been focused on what can be done, regardless of the cost of doing it. I remember there's this talk on Variedics. I'm talking about Variedics because I've been working on this book chapter in Embracing Modern C++ Safely book. So I've been working on this chapter, and I put a lot of effort into it, and I learned a lot. I thought I knew Verdict templates, but actually there's so much more to know once you get really into them. But I think uh, there's a need for the C++ language to offer ways that are uniform and simple and easy to achieve difficult things. Because this is the thing: people have focused in C++ on can this be done? And I remember that this is talk on Veredix and said, oh, so we can do this. If you just open namespace detail, write, 1,000 lines of code in namespace detail, you close namespace detail, then you say using, boom, and you're done. So, first of all, like, why the hell do I have to open a namespace detail? Every time you type namespace detail or whatever, reserved or whatever have you, right? Every time you open namespace detail, that's a failure in the language. It means the language cannot express what I need to go some places, do some dirty work and come back. So it means there's no clean naming, there's no clean like lambdas and clean way to do things without introducing names. So that's definitely a problem that is visible. And then why do I have to go through all of these difficult steps of achieving even the like apply a function to every element in a tuple, get a new tuple, and that that's a little thing. You just gotta kind of sit down and it's not easy. It's just not easy. And a lot of things are simply not easy. And Carbon and Simply Front, even though ABI reasoning and whatever were part of the motivation, I'm sure their offering in the C++ community is going to be, we can do what C++ does. It's just simpler and more uniform, more self-consistent, right? And I should also add that there's the Circle compiler and language extension. So there's a lot of work on Circle, and that's sort of a very nice, beautiful reflection-based compiler, which adds some extensions to C++. And it's an interesting, another proof, another piece of evidence that actually the community is at the crossroads. There are too many languages in C++.
Yeah, Emma. So we had last week a really interesting conversation with Sean Parent about all the various languages and how he works with his team, or his team working on VAL and being part of the other efforts too, and trying to get to maybe maybe they're converging on one language in the long time. We will see that.
Right.
There is a question.
May I dwell just for one more second? Yes, I'll dwell just 1 second on Carbon for a bit.
Yes.
Because CPP, like Herb's work is in a way sort of very backwards compatible. It generates C++, and it's just essentially a source to source.
I love that.
It's anchored within the C++ milieu. But Carbon is kind of a definite departure. And I think what Carbon needs right now, I think Carbon is in dire need of a great idea. And I'll explain what I mean by that. All right. So, okay. Turn the clock back to 1984, 1982, right? So 1984. So C++ came and it was all about objects. And even though it didn't do objects well, because there's like no virtual functions and there's no this pointer and like a lot of things Bjarne got wrong. Let's face it, it was it was the early days. So a lot of things Bjarne got wrong in the initial C++ version, but he got one thing wrong, right. And you know what that is? That is the class keyword. So Bjarne introduced the class keyword, which was technically unnecessary because the class is really a struct with like private and whatever. But essentially, he introduced this one keyword that I think changed the world, because he said, you can define a class and you can, put functions in it. And it was like absolutely amazing. Like everyone was like, oh my God, why didn't I think of this? Like, how this changes everything. And it did change everything. So in the 80s, it was the classes OOP, right? OOP. And then the 90s come, right? The 90s come, and then comes Java. Like Java was like the 90s. Like, whoa, you're like Java, and write once and pray everywhere, and whatever the hell.
All about classes.
Yeah. So, but then C++ came back, and it came with templates. So the 2000 was like templates, another great idea. Like, oh, we have templates, it's awesome, and that kind of stuff, right? So every decade, and then the 2010, the decade of the 2010s was safety. Rust was where the cool kids were like, oh yeah, this is awesome, So every decade has its thing, right? Has its great idea. And what I think Carbon needs, and I'm sorry, folks, you don't have it yet. You don't have it yet. What Carbon needs is a great idea that's going to take us to 30, right? So they need a great idea. What right now they have a lot of Me Too and a lot of we're not going to do that. We're going to do that, and we're gonna not going to do that. But they don't have like one great idea that everybody is like. Of course, this is awesome. I'm going to use carbon from now on. Okay, sorry for dwelling on this particular thing.
It's maybe one can see that as an advantage of not being too much in the real space already. But on the other hand, yeah, I mean, the other projects might have right now a bit of a head, and maybe they can get by avoiding the obstacles which other projects hit, or we'll
Right.
see. And as I said, I think the Arno I did a week ago, Sean Parent kind of made clear that there's a lot of vibrance and communication and exchange of ideas in this community. So things might be converging on something.
Awesome.
We'll have to see. But there's an interesting question I
I
want to
saw a
go
bit
to
of
now.
cute, right? Yeah, cutie. Okay.
Yes. So, what's your opinion about the reflection implemented in Qt and Unreal Engine, and how should it be the way for the standard to reach that goal and standardize reflection for everyone?
All right, so I need to confess ignorance here. I'm not sure how Unreal does it, and I only know the old way Qt did it, and it was kind of
Okay.
they had macros and stuff, and it was kind of self. They use like
Mhm.
standard C++, but they added a few macros and stuff. Is that correct? I'm not even sure that.
Yeah, it's a high level overview, and I think you're not like a Qt person, so we can leave it at that and then change to the standard. So what's your vision for
I
the
think
standard reflection?
right. So, per a famous politician, don't answer the question you asked. Answer the question you wish had been asked of you. So I'm going to answer the question that I wish people asked, which what is the way you you want to implement reflection? So I think getting back to this neoclassical C++, I think reflection should be done in a way that completely democratizes metaprogramming, like that makes it absolutely trivial for any rank and file programmer, anyone who's not an expert in C++, who's not a world-class template, whatever wizard, who is just one beginning programmer who has simple notions of how to write code. They should be able to do things like, because I just have this problem, and it's just so difficult. You write your constructor, and you want to do like this, the default, and but one more thing, the default plus a little thing, right? So you want to say, and for those for writing such a function, it should be trivial to say iterate all members of this class, initialize that member, and then do one extra thing after the loop. So you should be able to do a simple loop, for example, with reflection. Um, and I continue being indignant in a way that simple notions such as test and iteration are not considered top priorities for new features in the C++ language. They're like, oh yeah, no, we're gonna do this recursion in namespace detail. The hell, you don't, you shouldn't. Forget namespace detail. If I see namespace detail one more time, I'm gonna throw a fit, right? So there should be a simple way to do the simple things. Picture this: you're in C, but you don't have the if statement. Well, wait a second. So I need to do everything in a function with the question mark and with that nonsense. And you wouldn't want to code in that language. Who would? Who would? Why would you want to code in a language that offers reflection in such a way that you need to learn yet another language, sub language within C++, and there's no problem. There's gonna be no shortage of world-class experts who are gonna teach you how to do it at conferences. So to answer the question, I think the way for a standard to standardize reflection would be in a neoclassical way, with naming things, with iteration, and with test, and make it simple, make it trivial, make it democratic, and make it in such a way that everybody, not just the top 1%, can code with reflection.
That is a very good answer. There's a question which is simple, but I would like to read the full. It doesn't fit fully on here, so I want to read it. So Dennis Yaroshevsky asks, I'd like to say thank you that you had a massive impact on my career from modern C++ to design your talks on performance in 2013, 2014. And the question from him is basically, what is your experience with SIMD? So, SIMD.
Again, I'm going to answer the question I hope was asked. So I do have a bit of experience with SIMD, single instruction multiple data. So there's specific data types, there's specific alignments, there's a specific way to do things, and essentially it's a way of exploiting parallelism in repeated action. So I'm familiar at that level. So I don't remember I wrote any extensive code, but for example, there's a SIMD library for the D language that I used informally for a while. So I do have a bit of experience. What I do have a bit more experience with is CUDA, which is NVIDIA's. It's actually single instruction multiple tasks. So it's SIMT, SIMT. So it's a bit more powerful than SIMD, and offers more flexibility. And essentially, here's the question I wish was asked: how important do you think SIMD is, and how important do you think SIMD and SIMT in general, like this highly parallel work, is? And I would say it is survival at this point. I would just say, not to go like a crazy guy into like climate change and that kind of stuff, because it's not topical for a programming conference. But I do think we're in a race to save our planet from ourselves, right? And actually, these techniques of highly parallel code are the best instrument we have right now to do good things, which mean modeling, which means like things like climate modeling at the large scale. I'm not sure many people know, but right now we don't have computers powerful enough to even model more than, like, I forgot the scale, more than 1 square kilometer for like with good resolution. And what people do is like they model 1 square kilometer, and then they model another square kilometer next to it, and they try to kind of reconcile the edges, right? So it's kind of a mess. So our computers are not powerful enough. It's just like takes a long time to do anything interesting. So climate change is definitely a huge challenge, and I think parallel computing is our best hope right now for tackling it. Not to mention AI models that could actually provide answers for how to build things that are not impacting the climate too bad. So in a very concrete way, I think SIM D or T, like parallel programming, is an important weapon in our arsenal, and it's a very survival oriented thing that we have right now. And I would suggest that anybody and everybody should get fluent with these things. Clearly, there's going to be always a place for serial code, and a lot of the code that controls these parallel algorithms is serial. So no problem. You're going to be you're not going. There's not going to be a shortage of you only write serial programs. Sorry, we don't have a job for you. That's not going to happen anytime soon. But I do think that there's a huge importance that these highly parallel execution fabrics have. To give you an example, with an NVIDIA machine, you can literally launch hundreds of thousands of threads and do you can accelerate algorithms by tens of thousands of times, like not just like that, right? And it's funny because at many conferences we speak, I improved that by 5%, and I'm awesome, wow, this is like 5% in sorting or whatever the hell you do, right? 5% is nothing. How about like 5,000 times, right? How about accelerating by 5,000 times or 50,000 times? And so you're looking at things that take a week and that take a minute and that kind of stuff. So I think it's very important that we get fluent with highly parallel programming and push it forward.
If you do something useful with all the threads and the GPUs.
You gotta.
You also have to face that GPUs have not been used for fighting climate change in the past so much. Um,
Yeah,
but
definitely,
that's
definitely, it's up to us to use them for good. That's definitely another facet of the problem.
um, do you have any thoughts to share regarding the complexity of C++ and how to attract and encourage fresh engineers to practice and be updated
Wow.
with modern C++?
All right, so these are like two very different questions. So thoughts to share regarding the complexity of C++. We discussed that a fair amount already. Um, and I invite you and everybody else to think about a couple of simple questions. For example, looking at any application that you're working on in C++ or any library that you're working on, how much of that code is actually doing work versus setting up things or kind of helping the work being done. And unfortunately, a lot of times you have a lot of supporting code, just namespace detail, my favorite, right? And a lot of like specializations and little declarations and tricks and everything that people use. And there's one line that says, oh, I'm gonna compute a hash here. So, for example, like in the C++ hashing, standard library dedicated to hashing, how many lines actually do math, like divisions and multiplications and shifts and all the glorious work of hashing? Very few. So you're gonna notice that in the hash table in C++, the unordered set or map, you're gonna figure out there's not a lot of actual work being done, but there's a lot of talking about it, right? There's a lot of foreplay, if you wish. So definitely, complexity is a problem in C++, and there is a way to reduce complexity by adding to add features that reduce complexity, which is very interesting. And I discovered that while working on the D language. And it goes like this. So if you add a feature that does something entirely new, there's a lot of effort, there's a lot of cost to it, there's a lot of impact of it, and that kind of stuff. But there is a kind of feature that if you add, nobody's gonna notice. There's no complexity added. And this is like a secret I'm gonna let you in a huge secret right now, because there is a kind of feature in a programming language that you can add, and it does not make the language more complicated. It actually makes it simpler, and that is a feature that removes a limitation. A feature that removes the limitation makes the manual smaller, makes the definition of the language smaller, and makes the user happier because they're gonna like naturally just do that, and it's just gonna work. And let me give an example, Jens. Um, did you know that you can define a class inside a function? So you can write a function, and inside the function, go ahead and say class, whatever, and it works. So, and that's nice. And do you know that that class can have methods? Oh, yes, it can. And it can even have virtual methods, and it works, and it's pretty nice. And it can have constructors and destructors, and actually, local class with a destructor has a number of important use cases. But it cannot have a template method. There's, there's, you can't do that. If you try, like the compiler message is like it's even awkward. It's like it's like a bad first date. It's like, that I can't do that. I don't know why, but I can't do it. Right? Why can't you do it? There's no reason, and that's an artificial limitation that actually limits the way we can think about coding in C++. Because if you have a local class with full power of a class at top level, then you can define that and return it by means of an auto. And suddenly you have like a full idiom that you can define an entire class that implements a range, a view, an iterator, what have you, a constant, whatever have you, you can implement it inside the function fully encapsulated, and then you just return it by means of auto, and everybody's happy, and it's like just amazing. And it has a type that you can't talk about, like Voldemort type, right? And much like lambdas, they have a type but you don't know the name of it, and it's a wonderful idiom to use. And the fact that there is a limitation, it's actually more work in the manual and more work for the programmer. So there is a kind of complexity that um, is artificial in C++ that should be removed by means of these kinds of features. Remove limitations. Why can't I pass a namespace to a template? Why can't I do a number of things that I want to do, right? That should be natural, that I should just be able to do. Why can't I define a function inside of a function? Consider this: I can define a class, and inside the class I can define a static method inside the function, but I can't define a function inside a function. Why can't I? And believe me, in the D language, you can define a function inside a function, and there's very nice uses for that. So these are the kinds of limitations that should be removed, and the language would be better for it and less complex. Now, as to features that are complicated, like template variables, and like a variety of things that people added in, like really, like even like the talk today about coroutines. And the first, it was a great talk, by the way. So I loved it. And but the first sentence of the talk was, "Oh, coroutines are very hard, very difficult." Oh, coroutines! Whoa! So like 4 keywords, like just like the cost in keywords is like huge, right? So why do we have these really complicated things instead of like saying, "Well, let's remove features"? And how many features in C++ are sort of the dog that eats the cat that eats the mouse, that the mouse shouldn't be there in the first place? Like, how many features in C++ address problems that C++ had by means of an unforced mistake? For example, like concepts came because there's no easy way to constrain templates, because enable if was so difficult, right? And that kind of stuff. So there's a lot of complexity in C++ that is designed to fight complexity introduced by another feature. So yeah, I do have thoughts about the complexity of C++. As to attracting and encouraging fresh engineers to practice and be updated with modern C++, I think the simple ways to show good code. There's no alternative to showing good code. And if you can't produce good code that people see and like, oh yeah, sure, that makes a lot of sense, then then there's a problem with the language. For example, I took to Twitter. I forgot. So yeah, I think it was Twitter, and I said, how do you do? No, I took in internet at work. So I said, how do you compute the arity of lambda? The arity of a lambda. Like arity means how many parameters it takes, right? So there's lambdas with 0 arguments, 1, 2, and variadic arguments. So there's like there's a variety of lambdas. And it just so happened in an application I had the need for just the arity of a lambda, and it turns out it's not an easy problem. And when you write the code, so I found the code somewhere on an obscure site, and I pasted it on the page, and it looks so bad on the page, Jens, that I was ashamed of myself for showing it to my colleague who's an expert in parallel programming, but he's not an expert C++ programmer. So showing, I was like, you know what? Consider this is like an object file. Think of this .h as .o. Don't even look at it. Don't look. It's like editing a binary. Don't look at that inside that file. It just does the compute the arity of a function. It was something like absolutely an elder incantation from a weird book of wizardry. It was just like terrible, and it wasn't working well because it doesn't work with variadics or whatever. So how do you look at how do you introspect the types of a lambda? Like how do you look at what members it has? How many captures a lambda has? Simple question. You can't do that. You just can't. And it's a crazy thing that you can't. So I think the best way to attract and encourage fresh engineers to practice and be updated with modern C++ is to write good modern C++ code. If you can't write, then that's a problem.
Now I'm muted. So that was a good answer. Very insightful. I have an interesting question for you. You were once a strong advocate of scope guards. How has your opinion in this evolved?
All right. So I should mention that a number of things that I harped about. So actually, like being the squeaky wheel is a good thing, yes, because I've been advocating a number of things and they made it into the standard, which I'm very happy about. So, for example, STD unquote exceptions, which is instrumental for implementing scope guard. It's in the standard now. Even more, there is I forgot the name. It's being standardized right now. So STD. Uh,
Expected?
I gotta Google for this. So there's a facility in C++ 23 that actually implements scope guard and that kind of stuff. And it's right now in like TR3 or whatever, and experimental. I forgot, but essentially it's I don't know the details of it because I saw it, but I couldn't use it in the version of the compiler by NVIDIA I'm using right now. So I don't have experience using it. So I implemented my own. I wrote my own. So my opinion about scope guard is that it's very necessary for the style of programming you want to have. For example, in CUDA code, it's very frequent that you call up or you call a function and that function may fail. You may have the wrong version of the GPU. You may invoke you may make any number of mistakes that are not that are forced essentially that you can't predict. So then imagine you have a function that's like 5 of these calls, each of which may fail in that function. There's a control flow, if, else, loops, and what have you. And then every failure of doing so would need to restore the system to the previously known good state. So you need a very different style of programming of writing these 5 possible failing points. And I literally don't know of a better way than using scope guards. I literally know of no better way than with scope guards. Any style of programming you want to use is going to be extremely complicated, and with scope guard is the easiest. So my opinion has evolved in the direction that I consider it survival of the C++ programmer to use scope guards in today's code. There's no way you can survive without them and write correct code in the presence of exceptions.
That is true. So your book is going to have a chapter on scope cards.
Sorry, come again?
So your book is going to have a chapter on scope cards.
Definitely. So and that's kind of funny. You should mention that because scope guard in a way is not neoclassical because there's no classical equivalent of scope guards. It's a whole different style of programming, but it's something that the function creates the organ, as they say, right? So it's the need that creates the facility. So it's not that I like scope guard; it's that I find no alternative to it that's suitable. So once you decide you're going to have exceptions or any kind of non-local flow of control. So any kind of non-local flow of control, you're going to need to have ways of undoing, incrementally undo actions. So definitely there's going to be a place for scope guards in any neoclassical, if you wish, C++ coding style.
True. So there's one more question which fits in the banners here. Some of the ideas you raise are implemented in Circle. How do you see Circle related to C++ and to the other futures directions of C++?
I think Circle is a very interesting point in the design space around C++, and it has a very nice way of doing reflection. It has a lot going for it. I'm unclear how as I know from from personal experience, punching C++ in the nose is a difficult way to go about migrating from C++. So Circle, in a way, offers this proposition. It's like, you know what? So if you want Circle, you got to start using this new idiom, new compiler, new way of doing things, new everything. And I'm not sure how ready the community is for it. I'm not sure what path the community has. I'm working in C++. I have a million lines of C++ code in this application, and I want to start using Circle. And that is definitely a question that needs to have a very decent answer. Like maybe I can start using Circle and its facilities a very small percentage of the code base, and then start from there. My understanding is that Circle is a sort of a more radical proposition. So you gotta kind of compile everything with Circle. Um, and in D, it was initially the same. We're like, well, you got to rewrite your code in D, and that's the way to go. And then we learned that actually it's much better to offer people a migration path. And we made a number of changes to language in that direction. Those helped. Um, so I think for start, like the simplest thing that the C++ community and standardization community can do is look at Circle really closely and get inspiration from it. So that would be a simple way of going about things. Because Circle definitely has a lot of good things about it. By the way, in Circle you can't name packs, so I hate that. And
Okay.
if Sean listens right now, Sean, I don't like that. So please just fix it.
Okay.
And generally, like Sean is a very practical guy, and he implements the things that he needs and that he likes, and that's totally fine. But sometimes that goes in the way of what I think are good principles of language design, which are like generality and not avoid the hand of God kind of facilities. And I'm going to implement this, but it's magic, and you can't implement it outside the compiler and that kind of stuff. That is um, something common to all language designers. Language designers do that. Walter Bright does the same. He tends to build in the language things that I wish were in the standard library, and I think that's not a good way to go sometimes. But to their credit, like both Sean and Walter, they when they implement something within the language, it's a lot faster to compile. It's a lot faster to compile, and it's just like it's easy to use, and just use it, and it has a nice syntax because once you know the language, you can define your own whatever the hell syntax is most pretty. So I think at a minimum, Circle is a good source of inspiration, and as a maximum, it would be a kind of an idiom to migrate to. Um, but all in all, I think again, Circle, CPP2, and Carbon are three signs that the community is at the crossroads, and that's the important tidbit.
I think it's like really an interesting play field for ideas, and we'll see, if this culminates into a new language or into, C++, something added to the standard or something. It's a really interesting time to see this evolve. There's actually an interesting question which I would like to close this with. It doesn't fit on the banner fully, so I'll read it from Hubido. Recently, I heard from some experienced programmers like they don't prefer multi-threading. They prefer to do in a single thread. They believe multi-threading won't actually improve performance, even in scenarios where we usually think simultaneous, parallel execution. Any thoughts on this?
Um, like Sean Parent and I discussed, and Dave Abrahams, we discussed this at the conference, and it went like this: like people use multiple threads in Adobe at Adobe with in Adobe's applications, and essentially like the cost of maintenance is so high that they're and the gains in performance are not justifiable, and they're looking for alternative models to multi-threading and that kind of stuff. So there are many flavors of multi-threading nowadays, and when I say multi-threading, I assume this would be the old meaning, which is I start like a moderate number of threads, and they do a moderate number of things, and they improve the performance by a moderate amount on a good day. And I agree that's not a huge thing. But on the other hand, there are these more interesting threading model. Actually, coroutines would be part of the discussion, like green threads. All of these lightweight threads and cooperative multi-threading and that kind of stuff. And also single instruction, multiple threads, and single instruction, multiple data, which are you can also think of them as multi-threading. So in that sense, I would not agree with the statement that they don't improve performance much. I mean, it's a simple fact of life that if you program with single instruction multiple threads, the CUDA model, it's gonna have like absolutely like mind-boggling acceleration of code. It's just like there's no, and actually even the going from the mindset that I have like 5 threads and I'm kind of, wow, this is awesome, I have 5 threads, going from like, oh yeah, I have like 50,000 threads, and that's, oh, too little, I need more, right? So switching from those sparsity of threads kind of mindset to actually there's so many threads that I should and could use. um, that's a big deal. And I agree that 5 threads are not going to be like awesome compared to one. And yeah, so there's a lot of cost to it, and there's a lot of magic involved. And I remember, like, Herbs talks about that atomics and stuff, and
Yes.
so much.
So
Go ahead.
you mentioned the coroutine talk that you saw that which we
Mhm.
had tonight.
Mhm.
Um, and I think this is like fitting in this context, like doing multi-threading things in the style that it's not like multi-threaded looking and that it's more like normal code. Um,
Right.
what's your view on coroutines?
I think they're an important thing. I don't know much about coroutines as they're done in C++. Um,
Okay.
clearly, there's like, for example, in C sharp, they're a huge thing. Like, I forgot how they call them. There's a different name for them. But green threads. So there's a tradition. Like, there's a Erlang language, right, which had the green threads, and then there's like Windows had fibers and stuff, which is kind of a weird point in space. And then JavaScript introduces like these odd, like, whatever, and there's a continuation passing style. So there's a variety of styles that have something in common, and let me call that those green threads. And green threads are great for things like when you have networking connections and a variety of asynchronous work to do, and a variety of devices that you need to keep busy. So definitely there's a place um, in anybody's mind for green threads. And not to mention like the Go language, which would be maybe the latest language that explicitly makes use of green threads. So definitely they're a thing. And if you program a server, like anything connected to the internet or whatever, you know those would be like the go-to obvious solution to green threads. There's no better way to program these things. So there are good applications that are essentially that the green threads are the best solution for a category of applications, and that says a lot, right?
Yeah, I think that there's an evolving space, and we have to do a lot of education into the general programmer field to make them understand that. And I personally,
Most definitely.
know a little bit more about and see talks about what C++ standard is going for, and I think we're on the way to it, but we're not like really there where it's like for the masses, in my opinion. But we're getting there, I hope. And
Gotcha.
with that, I just generally want to close this after 1 hour. Um, thank you for coming. Thank you. It was an honor to have you. It was a great conversation. Loved the question. Thank you for the question to the audience. And final word is yours. Anything you want to plug, anything you want to say, now's the
Thanks
time.
for having me, Jens. It's a great honor to be here. Thanks, very many thanks to the audience who was here tonight. And closing thoughts, I would say write good code and put that extra oomph into it.
Okay.
All
Then
right.
thank you very much. And I will end the stream.